Science Show. My name is Dr. Moses Xavier, and I'd like to introduce a special guest. His name is Dr. Octopus. He is a renowned scientist.
Yeah.
Put that away, man. That's kind of weird. Take a seat.
Okay.
It's a pleasure to be on the show.
Oh, it's a pleasure to have you.
I just, let's get a final. What? Whoa, that was some earthquake. Totally trashed the
Massive,
studio.
8.4. Holy.
It's massive earthquake. Well, at least we got this new lovely studio to finish off our little discussion.
Exactly. So what's your next question for me?
Does each phylum have a developed circulatory, digestive system, nervous system, respiratory system, and like, how is that system help and organize the phylum?
So yes, there are certain systems that not each phyla have. So first there's phyla porifera, which is the sponges, of course. So they don't have anything really. They don't have a digestive system, they don't have a circulatory system, they don't have a respiratory or a nervous system.
Sound pretty basic to me.
Yeah, there's very basic. They have no development that's really helped them in their systems. Next there's phylum Cnidaria with the silent C, obviously.
Silent C always gets.
So they have the start of a digestive system and a basic nervous system. And the nervous system helps them detect their food, and they still don't have a respiratory or circulatory system to aid them. Next, of course, there's Platyhelminthes, where they take it up a notch. They have a nervous system with cephalization. Only some though, so they have slight development of a brain. Next, there's no respiratory system, no circulatory system, but they do have an excretory system, which helps them out a bit. The slightly cephalized nervous system allows for better thought processing, and the excretory system allows for better removal of the waste from the body. Next, there's phylum Nematoda, and they have a nervous system, also with some cephalization. They have the start of an open circulatory system, so it's not quite so good, but it's better than nothing.
Kind of like a transition. They're not as basic as the first three, but like we'll probably get into that more later.
We'll expand on that later. Then they have a better excretory system than the Platyhelminthes, and they have the start of a respiratory system. So this really allows them, this development has really helped them a lot. The open circulatory system, it allows for, along with the excretory system, allows for the often parasitic nematodes, right? Allows them to filter out their toxins so they can survive better. Next there's phylum Mollusca, and they have a digestive system. They have gills for the respiratory system.
Yeah,
Yeah, exactly.
Water.
And then they have a nervous system with a major nerve end. Octopuses, they have a closed
Octopi.
octopi. That's right. They have a closed circulatory system, and sorry, thank you.
Kind of mosquito. That's phylum. What phylum is that again?
That would be phylum Arthropodia.
Yeah.
Yes. We'll get to that later. So then, phylum Mollusca, yes. So the octopi, they have cephalization. And the respiratory system allows them in this phylum, for some of them to get bigger because they can get more O2, and the circulatory system also helps them. It makes them more efficient.
Sorry, I'm not a scientist like you. You know, like what is O2?
It's oxygen gas.
Oh.
Yes. So it allows them to get more oxygen, and then their closed circulatory system, it makes them more efficient. Yeah.
It's good to be more efficient.
So then phylum Annelida has those are like your regular worms, like your earthworms. They have a closed circulatory system, a complete digestive system, and have a respiratory system. They also have an excretory system, and the nervous system is present, but they do not have cephalization. So it just keeps getting a little bit better.
Kind of just, they can
So,
move around and sense stuff.
So once again, they're just getting more efficient, able to get out that waste that they don't want anymore. It just helps them out. And then there's Echinodermata, which is starfish. They have a digestive system, a nervous system, a respiratory system, and a closed circulatory system. They got it all. So that just, once again, it just allows them to be more efficient, allows them to adapt to different habitats if they need to maybe get out some more toxins or.
Yeah.
Then there's also phylum Arthropodia, like the mosquito that you just got for me there. Thank
Yeah.
you. They also have everything. They got a digestive system, a nervous system with cephalization, and they have a closed circulatory system and a respiratory system. So those have all allowed the phylum Arthropodia to really develop, and they have the most species of, well, any of the phyla listed. So they really they kind of just took over with their developments.
That's pretty great stuff. Thanks for having you here. But I think we just got a quick commercial break, and then we'll be right back.
Sounds good.
$1 a day. You can sponsor this little boy, Zaring, and his dog, Journey. They need your help. Please, just $1 a day for a month, and he can eat for a whole year.
Call now at 250-424-4244.
Welcome back, and you know, I got quite a few more questions here for you. Do you mind if I get comfortable?
Yeah, sure, go ahead, by all means.
That guy? You know, let's get started. Did you say you had a diagram of the evolutionary tree of the birds? Like, can you explain like the shift in complexity of the organisms?
I believe I can. Hey, tech guy. I need you again. There we go. It's just on my super fancy MacBook Pro. So like, yeah, we'll bring the camera up and you'll be able to see many things. So I'll just slide along here and point things out to you. So we'll start at the most basic, you know, the least complex, where it starts at the tree, and there's Phylum Porifera. They're very basic because they're asymmetrical, which means they don't have any symmetry at all. And then they're also acoelomates, so they don't have much going on for them.
And does it say here that they don't even have true tissue? Like,
next, you branch up the tree to your Platyhelminthes, which is, they have no body cavities, so they're acoelomate, so they don't have any room for any organs whatsoever.
but they're bilateral.
They're
right?
bilateral, so they're more complex. That's
Quicker movement and stuff.
they can get around. Next, there's Phylum Nematoda, which moves up in complexity, and that's your pseudocoelomates.
Whoa, that's a mouthful for sure.
Yeah, so still bilateral symmetry, which is always an advantage. And then also, these are your first pseudocoelomates, which means fake gut. So that basically, it allows them to be a little more complex, but they still can't really hold any real organs.
So they're like transition in between like simple
Yeah.
and complex.
Pretty much. So next we'll come up here to Phylum Mollusca. And those are your first coelomates, which means they have a gut, so they can have all your internal organs and stuff, which makes them way more complex than the other phylums we've already gone over. And then there's Phylum Annelida, and basically the only thing they got going on for themselves better than Phylum Mollusca is their segmentation. And then also they're back to still bilateral symmetry, of course. And then there's Phylum Arthropodia. Those are your crabs and your
Other
spiders and stuff. and your
insects and stuff.
insects, all sorts of things.
Nasty
Pretty much the
mosquitoes.
same thing, always Yeah. So it's pretty much the same thing. And then we'll go over here. And then there's your phylum Echinodermata. And they have your
Starfishes and stuff. They're
Starfish and
coelamates as
stuff.
well, right?
Yeah, also coelamates, so they have their guts.
Then they're right up there with phylum Chordata, which is us humans, right?
Exactly. They are actually pentaradial, which is just kind of different than the others. Not really an advantage or disadvantage. And then there's phylum Chordata, which we won't really talk about too much. That's what humans are. Anything with a vertebrate is in phylum Chordata, for the most part.
Well, that's fascinating stuff. Now,
Good stuff, right?
let's cut to another commercial break.
After the techie,
Grabs this, my awesome MacBook Pro there. You want to be a deer and grab us some water as well, Mr. Techie?
Oh, whoops! My bad, Professor Xavier.
Thank you. How are we cutting to a commercial break now?
The new Nike LeBron 5s. Only $500 at Foot Locker. The new Nike LeBron 5s. Call 9-800-457-9999 to cop a pair. Or just call 911. Because he's on fire!
$1 a day. You can sponsor this little boy, Zaring Deep, and his dog, Journey. They need your help. Please, just $1 a day for a month, and he can eat for a whole year.
call now at 250-424-4244.
And we're back, great commercial. So, can you list the 8 invertebrate phyla? And,
Easy.
like, give an example of each and, like, the Latin translation and stuff.
Oh, okay. That's no problem for me, really. So, first you got phylum Porifera, which translate in Latin is pore-bearing. So that is your sponges, basically. And then
they eat zooplankton, right? I heard that somewhere on the Discovery Channel.
that's right. They'll suck it in with their little flagellum things they might have to generate a current, and then they'll just filter it through pretty much.
Pretty basic stuff.
Yeah. So then you have phylum Cnidaria, which translates to nettle because of it's your box jellyfish and your sea anemone, so they'll like sting you. So that's where nettle comes from. Then there's your Platyhelminthes, which translates to flatworm, and that's your tapeworms and stuff.
Nasty buggers. My
They-
dog had one once.
They're gross.
I had to
Yeah.
put them down.
Yeah. Then there's phylum Nematoda, and that translates to thread. And they're also worms, and more examples of different nematodes. Then there's phylum Mollusca, and that means soft body. And there's clams and octopi in there. And then there's phylum Annelida, which is your little ring, which is your segmented worms, such as the regular earthworms you see every day and leeches. And then there's phylum Ectodermata, and that means hedgehog, sea urchin, plus skin. And that's your king of thorns starfish and your other starfish. And then there's, last but certainly not least, there's phylum Arthropodia, and that means joint foot.
I really hate those. I just killed one of those
Those
a while ago.
mosquitoes, yeah. And they're joint foot because of all their segments and such. And those are your insects, your mosquitoes, and everything like that.
No, that's pretty good stuff. Let's just cut to another commercial break.
I think so, yeah.
$1 a day. You can sponsor this little boy, Zaring Deep, and his dog, Journey. They need your help. Please, just $1 a day for a month, and he can eat for a whole year.
call now at 250-424-4244.
And we are back.
It's good to be back.
Yeah, it is for sure. Could you define asymmetrical and radial and bilateral symmetry for me? Just a quick explanation.
No problem, I can do that easy. So first off, we have your asymmetrical, and that is they don't have any plane around the body. They're very poor movers, such as your sponges.
They're kind of just blobs, like no
The-
real shape.
Most of the time they're sessile. They cannot move whatsoever. Then you have your radial symmetry, which is symmetry repeated around a center disc. They don't really have a head, and they're very slow movers. Sometimes they're sessile, but most of the time they just can't move very quickly. And then you have your bilateral symmetry. So that's when you're mirrored down a center line, such as a human or maybe an insect. They are very good movers. They have their anterior, posterior, dorsal, ventral, and lateral. So it makes it so they can just move any which way pretty much.
Pretty quick,
They're way quicker. And then
very agile.
very agile.
Can you explain how symmetry helps or hinders an organism?
Absolutely. So first there's asymmetrical, right? So they're either very poor movers or they can't move at all, they're sessile. So it basically only hinders it because they can't get away from predators if they're trying to get them very quickly or at all. They can't really get away.
Couldn't chase after prey or something?
No, they can't. They can't really go to where they want their food. So, and it's pretty primitive. Then you get a little more advanced with your radial, and it can move around a bit better. But they're still very slow movers. So once again, they can't really get away from predators.
They're not chasers.
No, they're not chasers really. Sometimes, but and then you got your bilateral, which is about as good as it gets. Because you got all your different anterior and posterior sort of things, you can move around all sorts of different ways.
Very agile.
Very agile, so you can get to where you want to go quickly and efficiently, and you can get away from predators. So, or you can be a predator and get your prey easy.
Is there a trend in symmetry?
Oh, absolutely. So, as I said, you got your asymmetrical, where it's basic, and then it goes up in complexity to become radial, and then eventually bilateral symmetry to be as advanced as it gets.
Is there a change in complexity of body design in the organism in the phyla?
Absolutely. What else would there be, really? So, obviously, you started with the acoelomate, as I'm sure I've went over a little bit. So that's your without gut body.
Pretty simple stuff.
It's basic, you know. They have the mesoderm everywhere between the endoderm and ectoderm, and there's no room for anything else. So you can't have any specialized organs or anything like that.
Keeps them basic.
It keeps them like simple as you can get. And then you move up to your pseudocoelomate, which is your fake gut, and those are your mesoderm around the ectoderm only, and it's not a true gut. It's a little bit more advanced, but still no real specialized organs. And then you got your coelomate, which is, it's about as good as it gets, really. You got mesoderm around both ectoderm and endoderm, and you got a true gut. So that's where you get the real advantage. The other ones are kind of hindering them because they can't get specialized. But the coelomate with the true gut, that's where it counts, because then they can have organs and stuff, and
You get all your complex organisms they have coelomate, as you said earlier, right?
yeah, exactly.
Is there a trend in the body plan as you move up like complexity with organisms?
Absolutely, as there is a trend in pretty much everything we're talking about right now, there's a trend in these body plans as well. So it goes from the acoelomate to the pseudocoelomate to the coelomate, where that's your complex organisms.
Like as you were saying earlier, like the first ones are like they're acoelomates, and then as you move up, you get the pseudocoelomate and then the coelomates. Let's just cut to a commercial break from our spot. $1 a day. You can sponsor this little boy, Zaring Deep, and his dog, Journey. They need your help. Please, just $1 a day for a month, and he can eat for a whole year.
Call now at 250-424-4244.
And we're back. What is the difference between a simple and a complex organism? Like, which phyla are simple organisms?
Okay, so that's pretty easy. So first you got your phyla Proifera, then your Cnidaria, then your Platyhelminthes, then your Nematoda, and that's really your transition. So those are all the simple phyla, with Nematoda being the transition. So all of them have coelomate, and the Nematoda has a pseudocoelomate, so that means they don't have a true gut, and the pseudocoelomate has a fake gut, as you could say. And so they don't have any room for specialized organs and stuff like that.
Keeps them
Lungs.
simple and basic.
Simple and basic. Very simple excretion system, and for mouth anus. Not even for all of them. And then, as you get more complex, they're all coelomates, so they have a true gut room for specialized organs and other forms of specialization.
Which ones were coelomate again? I know you said earlier, but like complex ones. Which one are those?
Which ones were they? The complex ones that are coelomates? Okay, so first you got your mollusca, your annelida, your arthropoda, and your echinodermata, and then also you have your chordata, and that's about all your complex organisms we have.
Just cut to one last commercial break, and then we'll come back with our final interesting topic.
The new Nike LeBron 5s. Only $500 at Foot Locker. The new Nike LeBron 5s. Call 9-800-457-9999 to cop a pair. Or just call 911. Because he's on fire!
Thanks to all you sponsors, Zaldeep has been able to afford a MacBook Pro. Unfortunately, his dog Journey has gotten a parasitic nematode and has to be put down. And we're back, just had one last question for you. How do these organisms interact with each other, and do they work together? And, are they ever harmful to each other or helpful?
That's
a couple examples.
That's pretty much all they do, is either they hurt each other or they help each other, or maybe a bit of both. So basically, for all their interactions, most of the time they're either eating each other or getting eaten by each other, but they also have some symbiotic relationships, like the crinoid, which is part of Ectodermata, and shrimp. So the crinoid eats the shrimp's leftovers, and the shrimp gets the protection from the crinoid. And so that's them working together, and then also they can be quite harmful to each other. So the King of Thorns will eat coral and destroy the reef. And that's about it, really, I think.
It was really nice having you, Just send you on your way.
I don't know what kind of look like.
We do kind of, it's kind of weird. I didn't notice it until now, but yeah. Except I'm better looking, of course, but no, it's
A little sketchy, but
a nice day.